A very early good morning to you from Rocket Lab Launch Complex 1 in Mahia, New Zealand, as we approach T-minus 19 minutes on the countdown clock to our next Electron launch. It has just gone past 4:10 a.m. here in New Zealand, beaming into you from the future on Thursday, the 27th of March. Liftoff is scheduled for 4:30 a.m. local time or 8:30 a.m. Pacific and 11:30 a.m. Eastern. So rise and shine, it is launching time for Finding Hot Wildfires Near You, a dedicated mission for wildfire detection company ORORA Tech. My name is Muriel Baker.
And I'm Grayson Leslie, and despite the early hour, it's exciting to be here to watch Electron take flight for the 5th time this year and for its 63rd launch overall. The Electron rocket live on your screen is standing tall on Pad B at Launch Complex 1 and will be our 3rd mission launched from the spaceport in just 2 weeks.
Yeah, incredible stuff. Now, Electron is carrying 8 satellites on board for today's mission for ORORA Tech and is heading to a 550-kilometre circular Earth orbit on a 97-degree inclination. Deploying today's satellites on orbit will provide firefighters and emergency workers with near real-time data on how a fire is behaving and situational awareness to better battle wildfires in their hotspots.
So today's launch is targeting a time period known as the afternoon gap. This is the time of day between mornings and evenings that can be missed by other satellites on a sun-synchronous orbit. It's also the time of day when fires start most often and rage the hottest. Today's satellites are being deployed to help fill that gap. Each of them is purpose-built with wildfire detection sensors and thermal imaging cameras for clearer images and a faster response to wildfires. Here's ORORA Tech with an in-depth explanation of their mission.
This is basically the first time that we are bringing out a real commercial product with our own constellation. 8 satellites in total. We're starting to deliver like our real-time fire service for the first time to customers. And this is like pretty exciting for us.
And now was the time where we wanted to scale up. So not only having one system for trying out, but now having 8 systems in space that are actually used by people all over the world in order to detect wildfires and to make the world a bit of a better place, so reducing the amount of massive wildfires.
I'm feeling great. So many things coming together with OTC Plan 1 launching finally. So with putting a total number of 8 satellites, a constellation out there, and if you realize that up to date we only have 16 satellites in total globally doing fire monitoring, and we couldn't put 8 in one spot in the afternoon where there is no data. So there is a spot in the afternoon where most of fires peak and most of fires start. And also in the night, we do have a problem in fire management where there's no remote sensing data at all. And we're going to put these 8 satellites exactly in that spot and serve our customers for the first time with this critical data where there is no other data.
That's where most of the action happens. That's where the fires roar the biggest. And also in the night, when they start their shifts in the very early morning, talking about like 5 o'clock, they need data so they know where they want to tackle next, what they want to do, and how they want to attack the fire. And that's something with our first constellation and with WFS Pro we're going to start to deliver.
I give you one example. You should imagine regular people, foresters, using our modeling on their mobile phones in the field to calculate where fires are spreading in real time, and using real-time data from space and connecting that world, the regular people, all of us, to space data seamlessly. That's the job we're doing. So that's ultimately, it's not about the satellites. Satellites are nice, satellites are important to get the data, but the real thing going on here at ORORA Tech is the connection to the end user.
Building up a system that is easily accessible for them, that when they're out in the field, that they can get notifications on their smartphone, that they can have all the relevant information in one system. So they're opening the map, they have all the information that they need, and assisted by a lot of other sources that are available that we brought together and made it easily accessible to our customers.
Obviously, it's a lot of sweat and hard work to pull that off. I'm also proud of our partners, Spire and Rocket Lab, in this. So I think it takes a lot to pull this together.
We have been working together with Spire in order to make this full constellation possible.
Spire is proud to support companies like ORORA and others around the world in scaling their constellations, particularly for climate change applications. Spire has built over 200 satellites for its own constellation and for their customers, and we're extremely proud to help ORORA do the same.
We are working together very closely, and we are very happy to have Spire on board this mission and making this a great success and bring up the very first wildfire detection satellite constellation.
ORORA's expertise is focusing on the payload and their data processing to detect wildfires with low latency. Spire's expertise is focusing on the satellite and the manufacturing to get assets to orbit quickly and reliably. Spire is happy to partner with ORORA on this mission.
Yeah, so that was such an amazing experience building this.
To see that vibe and the force, the sheer force happening here to change things, that's really energizing. That energizes me every day.
I think bringing this live has been an extraordinary challenge, and an extraordinary challenge that we were only able to master because we have one of the greatest teams in the world.
Yeah, I want to say thank you all for supporting us. Thank you to the team for this effort, and Godspeed OTC Plane 1. I'm really looking forward to the launch.
Thanks, Mark. Really appreciate it.
Thank you.
All right, T-minus 13 minutes, 12 seconds and counting. And we are coming up shortly on today's no-go poll for launch. Now, each operator in mission control and range control will tell today's launch director, Michael Pearson, whether they are go and ready to move forward with the count or no-go if they are not. So let's turn up the audio from mission control now and listen in. The kick stage and perform a deorbit maneuver that can reduce its lifetime in space to help minimize space junk. It is also 3D printed, and it can be operated autonomously without constant control from the ground, which makes it great for missions that are deployed outside of a ground station's range. Now, after today's launch, the kick stage's deployment count will rise to 224 satellites delivered to orbit from across 63 missions in total. Our rocket is a leader in the launch industry, with its capabilities put to good use by small satellite missions like today's that require a regular, reliable and precise ride to space.
Closer to Earth, there are even more missions our rocket serves below the Kármán line. We build, launch and operate
last year. And with at least another 5 HASTE missions locked in for the DoD and its contractors this year and next, you can expect to hear a lot more about our Hypersonics Accelerator and its missions from Wallops Island, Virginia.
Today, though, we're at T-minus 5 or so minutes to liftoff, which means very soon Electron will switch to its internal power and flight computer to run the rest of the countdown autonomously. Soon after that, Electron's launch safety system, the Autonomous Flight Termination System, or AFTS, will be enabled for flight. Both of those actions should be heard across the nets from Mission Control when they happen.
Next on the list will be the completion of propellant load to Electron, followed by propellant tank pressure optimization that makes sure they're at the right pressure levels for launch. And that should happen within the final 60 seconds to liftoff. Then it's over to the 10-second countdown by the launch director, with Electron's Rutherford engine set to ignite at T-minus 2 seconds before launch. The hold-down mechanisms will be released around the same time for Electron to take flight at T0. Now, only a couple more minutes to go until all of that takes place, so let's switch over now to listen into Mission Control and hear the final countdown to liftoff.
LD GC mission.
GC LD.
ECS is disabled. Pad auto sequence is armed. Pad is ready for launch.
Copy all. All stations LD on mission. From now, there should be no red flags on your critical LCCs. VCON LD mission.
LD VCON.
Lock auto sequence and confirm.
Locked.
Confirm all flight computer ASGOs are green.
All ASGOs are green.
And at all stations, we are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
The vehicle is fully on the internal power. AFTS is green and enable for flight.
Lock slot is complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purge enabled.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
Beginning pitch over.
Electron is cleared to power to see for launch pad.
Stage 1, propulsion nominal.
All right, liftoff for Electron's 63rd launch, and we are on our way to space for this wildfire detection mission for Aurora Tech. Now at over coming up to 5 kilometres above Earth and travelling at over 900 kilometres an hour. Soon you will hear our operators announce Max Q, the point in the rocket's ascent that it experiences the highest aerodynamic stress. So let's listen in for that call.
Cleared Max Q.
At T plus 1 minute 15 seconds and counting, that is Max Q cleared by Electron on its way to space. Telemetry is looking good, with Electron now traveling faster than the speed of sound at more than 2,000 kilometers per hour. Next up is MECO, or main engine cutoff, followed by stage separation and then second stage engine ignition. MECO is when all 9 Rutherford engines shut down to slow Electron's pace just before the second stage separates. Once that happens, the engine on stage 2 will power up to continue the momentum to orbit, with the engine burn running for several minutes to propel the second stage with its payload. Let's watch it all unfold on our screen in just a few seconds.
"15 seconds to staging."
Entered burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
There we go. That was MECO, stage separation and second stage ignition as planned and confirmed, but what we heard across the nets and saw from Electron's onboard cameras. Travelling at more than 8,000 kilometres per hour now, up next is fairing jettison to separate the nose cone from the second stage. Let's stay with Mission Control and see if we can catch a glimpse of them too as they fall away.
Fairing jettison confirmed.
By fairing and hello space for Aurora Tech satellites, now exposed to those vacuum conditions above Earth as the mission continues nominally.
AGB discharge holding nominal.
Electron's second stage Rutherford engine is continuing nominally, keeping the mission on track towards its target 550-kilometre circular Earth orbit. Now, the engine has a 6.5-minute burn time before its scheduled stage separation with the kick stage at T plus 9 minutes and 5 seconds. So now that we are at T plus 4 minutes, nearly 5 minutes and counting, that leaves us with another 3 to 4 minutes or so to go in the countdown to engine shutoff.
Some things you'll hear from Mission Control shortly will be HVB battery discharge nominal and approaching hot swap, both of which are call-outs related to the battery packs connected to the second stage's Rutherford engine. Those batteries are keeping the mission moving as they power the electric pumps that provide both fuel and oxidizer for Rutherford's combustion. But like all batteries, the longer you use them, the more they drain of power. With the second stage engine burn lasting longer than its first set of batteries, Electron performs a switchover that taps into the next set of batteries while the engine is still running. The maneuver is called the hot swap, and it's a critical next step in the second stage's journey to orbit. Let's watch and listen.
Guidance is nominal, 200 seconds remaining.
HUB discharge holding nominal, approaching hot swap in roughly 30 seconds.
Throttling down.
Battery jettison confirmed.
There we go. That is battery hot swap confirmed from what we heard and have seen just now. The mission is continuing nominally along its trajectory, now past 200 kilometres in altitude and getting close to its required orbital speed of around 27,000 kilometres an hour.
AFTS has saved.
We have about 2 more minutes left in this second stage engine burn before Electron reaches its nominal transfer orbit and separates the kick stage with its satellites. This refers to the planned and expected trajectory the mission will follow when moving from one orbit to another.
Because the kick stage is released in an elliptical pattern, a transfer orbit will bring the kick stage to the altitude of its planned circular Earth orbit. And that journey takes about 40 minutes or so from the moment the kick stage is separated from the second stage. Now, once the kick stage reaches its target, its own engine will light up to perform additional maneuvers that circularize its altitude for that desired payload drop-off.
Before that happens, first we have to pass through engine shutdown on stage 2 and the final stage separation. It's a similar process to what was achieved with Electron's first and second stages just minutes ago. Stage 2's engine will throttle down and shut off in preparation for separation before the kick stage is released and sent on its way with Aurora Tech satellites.
Entered burnout detect mode.
Guidance is in terminal, 20 seconds remaining.
SECO confirmed.
There we go. That was SECO confirmed on the second stage and a successful deployment of the kick stage to its nominal transfer orbit. Great news for the team and the mission so far. Now, with that work done, we still have the business end of the mission in 40 minutes or so. And so as we talked about, we're now in an elliptical orbit until the kick stage can perform its engine burn to place that mission on its circular orbit. And that will happen when we get to the other side of the planet. So we'll come back and join you to listen into those final moments then before payload deployment just after the top of the hour.
Until then, you can follow the kick stage's journey with this tracking graphic as it continues in its coast phase around Earth. See you back here soon.
The kick stage in preparation for payload deployment coming up in just a few minutes.
Since the kick stage's release from Electron, it has since completed its first pass of Earth and lit its Curie engine to position itself in a circular orbit. We're now waiting for confirmation that the engine has shut off, which will mean we're just moments away from payload deployment for Aurora Tech. Let's listen in now for the calls from Mission Control for confirmation that engine cutoff has occurred.
Curie cutoff confirmed.
Nominal final orbit achieved.
Curie shutdown is confirmed. Excellent news for the mission. Now less than a minute until the 8 Aurora Tech satellites are released from the kick stage to begin their wildfire detection mission.
The satellites will be released from their dispensers 2 at a time across 4 events, and the first deployment is now just moments away.
Deployment of payloads Untitled, SC and Esperanza confirmed.
That is 2 down, 6 to go for Aurora Tech. Now each deployment takes place within seconds of each other, so we won't have long to wait for the next pair to be released.
Deployment of payloads Krempel Bro 2 and Thermoraptor confirmed.
That's 4 down, halfway through the deployment sequence here. 4 more to go in the next minute or so.
Deployment of payloads Krempel Bro 2 and Till Infinity confirmed.
6 satellites on orbit now for Aurora Tech, only 2 more to go to complete the full payload deployment.
Expected deployment of Neuro Spicy and Langer to space.
Now on their journey to finding hot wildfires near you, that's mission success for Electron with payload deployment confirmed.
Congratulations to the team and welcome to orbit for Aurora Tech. Your mission is now underway. So that's 224 satellites delivered to space, 63 missions, 3 launches in 2 weeks, all achieved by one team. So well done to everyone involved at Rocket Lab with another mission success for Electron. And we'll be back to the pad again soon with our next launch from Launch Complex 1.
As always, thank you for joining us and sticking with the mission right to the end. Stay locked to our social media feeds for up-to-date information on all things happening in the lab. Until next time, this is Rocket Lab Mission Control, signing off.
Dark we rise and soar, guided by the dreams we wore. From the oceans to the skies, endless fire burns in our eyes. Beyond the stars we chase the light, with fearless hearts through endless nights. No frontier can hold us down, the universe is our playground. Mountains high and oceans deep, secrets in the void we keep. Every step a tale to weave, for those who dare, who still believe. Beyond the stars we chase the light, with fearless hearts through endless nights. No frontier can hold us down, the universe is our playground. Is our playground. Mountains high and oceans deep, secrets in the void we keep. Every step a tale to weave, for those who dare, who still believe. Beyond the stars we chase the light, with fearless hearts through endless night. No frontier can hold us down, the universe is our playground. Echoes call from far away, guiding ships through cosmic sway. With every launch a new sunrise, the quest for knowledge never dies. Beyond the stars we claim the skies, bound by hope.